Hello, welcome to my YouTube channel. Myself Ankit Yadav, and on this YouTube channel we are going to cover about the topics of physics from today onwards. And first, the course which we are going to deal is classical mechanics, and we will be posting videos regularly on this YouTube channel about physics content only. Okay, so first we are going to deal in classical mechanics. So this is lecture 1 on classical mechanics. First, let me introduce to the syllabus which we are going to deal in classical mechanics. This is basically the new syllabus which is given by Delhi University on classical mechanics for the first year students. And this is so first we are going to let me zoom it for you. First we are going to understand about the fundamentals of dynamics: inertial and non-inertial frames, rest, motion, Newton's laws of motion, Galilean transformations, and all those things, principle of conservation of momentum in the first unit. And then afterwards we will move on to work and kinetic energy theorems and the many like collisions and elastic collisions. In second unit, as you can see from here, we are going to move on rotational dynamics, and in third unit we are going to deal with central force motion, Kepler's laws, planets revolving around the sun, and other central force systems. And in the fourth and the final unit, we are going to cover like the special theory of relativity and Lorentz transformations, in that time dilation, proper length and proper time, and many relativistic phenomena which we are going to deal. Okay, so this is the syllabus. Now the reference books for this syllabus are given by the university are these ones. So this one, an introduction to mechanics, Daniel Kepler and Robert Kolenkov. This is a very good book which we are going to study, and you can also follow up on this book. It's a very well read read. You have to go through the books now and then in order to understand the concepts more beautifully. Okay, and one more book is for the for Indian students. It is sometimes a little difficult to understand the books written by foreign authors. So we have given the name of this one, Mechanics by D.S. Mathur. Okay, this is also a good read. You can go and read this one, go and purchase this one also. Okay. Now, one more read is it's a very interesting book, Feynman Lectures. It's a book which is you can say the compilation of notes or lectures given by Sir Feynman, Richard Feynman. Okay, and it's also a very good read. For problem solving, you can have a look on this book, Theory and Problems of Theoretical Mechanics by Spiegel. Okay. So now, without further ado, let's carry on with our lecture. So first and foremost thing which we can ask the question in classical mechanics, basically it is designed like that. What is rest and motion? The rest or motion, these phenomena are defined. How do we define it? From one standpoint, we can say that the object is in rest. From other standpoint, we can say the object is in motion. If you don't understand it, let me I will give you an example in some time. Before that, let's understand reference frame. From a reference point, we can tell that the object is in motion or rest. Okay, one object can be in rest according to another object, and it can be in motion with reference to another object. Okay, so it is very important to define the reference frame. Okay, so what is a reference frame? First, let's understand. A system of coordinates axis which defines the position of a particle or an event in 2 or 3 dimensional space is called frame of reference. Okay, let's see. Here we have an example. Let's see. This one, boy A, boy B, and boy C. A and B are standing on a moving vehicle. It is going at a velocity v. Okay, constant velocity or any. So according to B, A is in rest or motion. A and B are not moving; they are sitting there on the vehicle, and the vehicle is moving with the velocity v. Okay, and C is standing on the roadside. So according to B, A is not in motion. According to comparatively to him, he is on the rest. But according to C, as the vehicle is moving in this direction, A and B, or we can say A is in motion. So what will we say? That A is in motion or in rest? We can't say कि A is in motion or in rest without defining the reference frame. कि हम कहाँ से measure कर रहे हैं? That is very important. Okay, so according to B, it is in rest. According to B, it is in rest. A, according to B, is in rest, but A, according to C, is in motion. Okay. So this is now. So you have understood what is a reference frame. So now to understand it more clearly, say for example, we will take a Cartesian system of coordinates. There are many coordinate systems which we can use, but like right now, I will give an example about the Cartesian coordinate system. Cartesian system of coordinates. Okay, Cartesian system of coordinates, for example. For example, X, Y, Z. O. This is a system coordinates. O is fixed at a point. Okay, and in this direction we can move. This is in X direction we can move. Okay, in Y direction and Z direction. Okay, so from point O, let's say this is a point P. Okay, this is a point P, which we can define like this. It is X distance at X point from O, X at a distance of X. Okay, in Y direction at a distance of Y, and in similarly in Z direction. Okay, the position of the particle. So the position of the particle is defined by these 3 coordinates. Okay, position of particle is defined. Position of particle is defined by three coordinates. Okay, X, Y, and Z. Okay, along 3 perpendicular sorry, 3 perpendicular axes. Along these 3 perpendicular axes, we have defined from X the distance is this, from Y the distance is this, and from Z. if we drop a perpendicular on the point, that is the distance on that side. Okay, अगर x में मेजर कर रहे हैं तो पॉइंट P से x के ऊपर एक परपेंडिकुलर ड्रॉप करेंगे तो x में वो कितना उसका डिस्टेंस है, सेम सिमिलरली विद y, सिमिलरली विद z. ओके ओके, नाउ द पोजीशन वेक्टर, जैसे r from point O, let me choose a different color, from point O I will draw a vector to point P. Okay, this vector is known as r vector. This is the position vector of point P. Okay, and this position vector defines the position of the point P. Okay, and we will write it like this: x I cap plus y j cap plus z k cap. Okay, in this I j k cap, these are unit vectors. These are unit vectors along 3 axes. These are unit vectors along 3 axes. So like this we define the position of the particle according to a frame of reference. We have to see from which point. If let's consider, if point P is fixed and O is moving, okay, and this coordinate system is moving with the velocity v. If this happens, this is moving with velocity v, then point P is in motion with respect to this frame of reference or this point O. Okay, so yeah, so rest and motion are relative phenomena depending on the reference depending on the reference frame. Okay, now position and state of a particle, position and state of particle may appear to be different from different frame of reference. As we have seen, position and state of motion may of a particle may appear to be different from different frame of reference. अगर दो different है, एक rest में है, एक motion में है frame of reference, तो एक के according, उनके according it can be different. उसका motion में है या वो rest के अंदर है. Okay, जैसे one more example I have given here. The example is a stone dropped by a person. A stone dropped by a person from window of a railway carriage in uniform motion appears to fall vertically down, but to a person outside the carriage, it appears to take a parabolic path. Okay, you can see the agar ek stone, one man is standing in the train. Okay, again let me make a train. Okay, this person is standing there and he drops a ball. So the path of the ball, and one more person is standing here. Okay, train is moving with the velocity v. Okay, if person A drops a ball, then the path of the ball will appear different to person A and to person B. To one person it will to person A it will seem like that the ball is dropping is or falling in a straight line, but to person B it will appear that the ball is falling in a parabolic path. Okay, yeah. Now moving ahead, this is all about frame of references. Now let's have a review of Newton's laws of motion. Sir Isaac Newton gave Newton's laws of motion. So the first law is a body must continue in its state of rest or of uniform motion along a straight line unless acted upon by an external force. कोई भी body है, okay, it will continue to be in a state of rest or in uniform motion along a straight line unless any external force acts on it. Okay, we will prove it in some time, but कि अगर कोई object है, if it is in rest, it wants to be in rest. If it is in motion, it wants to be in motion. And अगर कोई external force हम नहीं लगाते, then its state of motion will not change. Okay, yeah. Now we are like, let's have a look at the second law also. Second law says the rate of change of momentum is directly proportional to the impressed force and takes place in direction of force. The rate of change of momentum is directly proportional. Rate of change of momentum is defined by P is equal to mv. Okay, this is momentum is defined by mass into velocity of the particle. Okay, so the external force is directly proportional to d by dt of mv. Okay, P is momentum and mass into velocity, as I have already written it here. Okay, this is a second law of motion, and another condition which is necessary is it and the impressed force and it takes place in the direction of the force. Okay, now let's have a look at the third law also, and let's have a look at the third law also. To every action there is an equal and opposite reaction. One object A and object B, if object A applies a force F on object B, then object B will also apply the same amount of force B, but in the opposite direction. Okay, like F AB is equal to minus of F BA. All of this we have studied in, this is a vector quantity. All of this we have studied in from 9th onwards. This is not a big thing. Okay, now, and there must be two objects. It is a very mandatory quality that for the third law there must be two objects, and one object cannot exert a force on itself. Okay, there must be two objects in order to have an action and reaction pair. Okay, for action and reaction there must be two objects. There must be two objects for action and reaction. Okay, one object cannot do so. Okay, now let's move ahead. Now, Newton's first law of motion is a special case of the second law. How? We have already defined the momentum. Momentum is mass into velocity. Okay, and we have defined the second law as F is equal to dp by dt. Okay, F is equal to dp by dt. Let's put the value d by dt of mv. Okay, have it. M, if m is constant, m we are taking constant here. Okay, constant, m is constant here. Ma, a is acceleration of the particle. Okay, so if force is equal to 0, then mass is constant, mass cannot be 0. Acceleration is equal to 0. Okay, acceleration is 0. If force is 0, then acceleration is 0. So it is like this. If we do not exert any force, then acceleration is 0. Acceleration is 0 का मतलब क्या है? Acceleration क्या है? Basically, change in velocity upon time. Change in velocity upon time taken. और yeah, so कितना velocity के अंदर change हो रहा है? If force is 0, acceleration 0, then acceleration is 0, then the change in velocity is also 0. It means the velocity is equal to constant. Velocity is equal to constant. So from here we have seen, from first law what did we say? कि अगर, let's come to first law again. a body must continue in a state of rest of uniform motion along a straight line unless acted upon by an external force. अगर force 0 कर देते हैं, then there is no change in velocity. Okay. So we can say, so first law is a case of second law of motion. Now have a look at the limitations of the laws of motion. There are two limitations which we are going to discuss. Second law would not be good if mass does not remain constant. अगर mass constant नहीं रहता है, then second law will tremble. So the example is rocket. We have a rocket, and when we will discuss the motion of rocket, we will see that how it falters. We have to get back to the law of conservation of momentum in order to prove this phenomena. Okay, we will see what happens. Okay, in case of rocket, what happens? Rocket is going upward with the velocity v and exhausting gases. Exhausting gases in the back. Okay, so as the gases are going down, so the mass of the rocket is changing. As the mass of the rocket is changing, so the second law does not hold good there. We will discuss this example when we will discuss the motion of rocket. We are just telling the limitation here. Second thing is कि अगर mass change हो रहा है, in which cases? One तो mass is changing, mass changes in this phenomena. In like where else the mass changes? Mass changes in case of the particles with particles with relativistic velocities. Particles with relativistic velocities, there m is equal to m naught upon root 1 minus v square by c square, as you will see v is equal to c. अगर v या फिर v is approaching c, ठीक है, when v approaches c, what will happen? V will be equal to c, this will become 1, this quantity will become 1. Okay, 1 minus 1 0, then mass will be tending to infinity. As mass tends to infinity, then it again fails. Second limitation. Force exerted by two interacting bodies over each other are equal and opposite provided both the forces are measured simultaneously. दोनों bodies पे, interacting bodies पे, ठीक है, the forces must be measured simultaneously. ठीक है, that is the necessary condition. The force exerted by two interacting bodies over each other are equal and opposite provided both the forces are measured simultaneously. Okay, now we will stop the lecture here only. Okay, so thank you for paying attention, and welcome to this YouTube channel with me, and let's see where we go with this. We are going to post a lot of videos on physics, and I hope the content will be of value to you and to students, and not only of Delhi University but of any university, because the topics does not change. These topics are forever. And yeah, thank you. Please don't forget to hit like and subscribe. Thank you.